I am always fascinated by the tooling which deals with neural network architectures. Still, I believe we don't really fully grasp what goes inside these large language models, and that is why when I stumbled upon this tool which is called as NN-SVG that allows you to create neural network architecture schematics very easily, I was quite intrigued. So in this video, not only I'm going to show you the tool, I will also show you what exactly is meant by different components in as simple words as possible without going into machine learning mumbo jumbo. I will also show you the way how you can create your own neural network architecture schematics if you are into it, and we will also look at few of the use cases. Let me quickly show you the tool. So this is a tool, and look how cool this diagram looks. This is a schematic diagram of a neural network. A neural network is simply a computer software which is inspired by human brain structure and functions. It is designed to recognize patterns, learn from data, and make decisions or predictions. A neural network consists of interconnected nodes or neurons that processes and transmit information, as you can see here in this diagram. So I'm just scrolling my mouse to make it a bit bigger. At a very high level, there are three components of a neural network: input layer, hidden layer, and output layer. In the input layer, it receives the data to be processed. For example, in image recognition, the input layer would receive the image pixel values. Then comes few hidden layers. These layers between the input and destination output layer perform complex calculations and transformations on the data. They primarily help the neural network or model to learn patterns and relationships, as you can see with these lines going across. Finally, we have this output layer. This layer generates a final prediction or output based on the processed information. Now, this tool, which is NN-SVG, deals with three styles: FCNN style, LeNet style, and LXNet style, and I will be showing you all these three very shortly, and I will explain in very simple words what it means. Let me also introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language that turns any web page into a data source. It is quite resilient, it is reusable, and I will drop the link to its website in video's description, so please do check them out. Going back to this NN-SVG, as I said, it deals with three types of architectural styles. First is FCNN, which you can see on your screen at the moment. It stands for Fully Connected Neural Network. All neurons in each layer are connected to every neuron in the next layer in this one. It is simple, it is traditional, and most of the time you will see this thing in action. If you're looking to do basic tasks like classification, regression, then this is quite suitable for that. Next style is called as LeNet style, and they also have papers on all of these styles, by the way. LeNet style is also called as convolutional neural network, or CNN. It is primarily designed for image and signal processing, and it uses convolutional and pooling layers to extract features. It is quite old. I think it dates back to early 1990s. And it was used at that time for handwritten digit recognition, I believe. Then we have LXNet style. So LXNet style, it is a deep neural network, and it goes into deeper architecture with multiple convolutional and pooling layers. It was introduced around 12 years ago in 2012, and it improves image classification accuracy. There are a lot of parameters and layers in it, quite complicated. And I haven't really seen it being used that much, but still very much in vogue. So if you look here, if I go back to this FCNN style, and if you look on the left hand side, these are all the parameters and stuff or configuration which you can set in this tool. It is live HTML page, by the way, and I will drop the link to it in video's description. You can change the style. For example, you can put the edge width proportional to edge widths, and then there are a lot of other things which you can do. For example, you can change, and every, by the way, style has its own architectural weight and width and height. So I'm just going to go the FCNN because rest of them are the same ones. You can also change some of the rendering option like web graphics library or SVG. And by the way, SVG stands for scalable vector graphics. It is for vector graphics and also being used by D3 JS script. Anyway, so you see that we have, you can also, instead of these, you can go with the Bezier curves, which look really cool. And then you can set a lot of things around. If you want horizontal or if you want vertical, it gives you how it connects to each other. And then you can increase the number of parameters and layers and weights. There you go. So I'm just increasing it. It is becoming more dense and more complicated. There you go. And you can of course increase the layers, and then you can just keep adding them, like I just clicked on this plus sign, and then you can also select any random weights. So similarly, you can deal with the other style, same stuff. You can change the architecture and it is going to put in more weights for you. Now, why would you need these sort of schematics? Well, sometimes you just have to clarify complex concept. For example, if I have to describe neural network in simply in diagram, I would use this with this schematic. I would like, if I have built a model with certain layers, if I want to share that model in a schematic architecture, I would use this. We could use it for collaboration, for planning and design between the machine learning teams. And for example, I need some diagrams from my research paper, I could also use this. Now, next question is how you can draw or locally do it. Well, you would need this API. All you need to do is to use JavaScript, and then in your Java code, you can draw with this. And this is how you create the neural network. This is all pure JavaScript. And then this is where you are giving it the dependency and stuff. And this is how you draw FCNN, LeNet, and then LXNet. It's all pure JavaScript code. So if you're a Java developer, you can easily build it. How cool is that? And as I said, it is all available for free on their website, and I will drop the link to it in video's description. So please do check them out. Also, if you really are deep into this stuff, I would highly suggest that you go to their repo. From their repo, you see they also have given the links to the papers. Really good read. And if you want to go deeper into these neural networks and machine learning, a very fine read. But if you don't, that is fine either. So that's it. I hope that you enjoyed it. Let me know what do you think about this NN-SVG. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.